Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at one of the, of course, particular examples of finding the concept of skewness and kurtosis. And this is going to be an additional concept, which, of course, we are going to employ one of the methods that we have discussed on the moment coefficient of skewness in trying to evaluate this specific, of course, problem set. Now, in this case, if we are given a specific set of the moments of distribution given in terms of the first moment, the second moment, the third moment, and the fourth moment about a mean, we're going to use this specific data in trying to evaluate the concept of skewness and kurtosis by using that specific method of the moment coefficient of skewness. Now, I mentioned from a previous video that we can use specifically three ways of measuring skewness. And that, of course, was the measure of skewness using the Pearson's coefficients of skewness. And then I mentioned the concept of Boyle's coefficient of skewness, which depended basically on the concept of quartiles. And then lastly, I mentioned the concept of the moment coefficient of skewness. And in this case, having looked at the three specific methods, the first one basically the Pearsonian coefficient of skewness was given in terms of the difference between the mean, the mode, and the ratio of that with the square, or rather the standard deviation. And this, of course, was the Pearsonian coefficient of skewness. The second method, which I've mentioned basically, was the Boyle's coefficient of skewness, which is dependent on the concept of quartiles. And we are given from this specific case a representation for a particular set of quartiles, which was given in terms of the skewness is given as the sum of the third quartile and the first quartile, and the difference of that one with the second quartile, and then we had this one given in terms of that one, and the difference between the third quartile and the first one given as such. So basically, we're going to also look at this particular case. And the last one I mentioned was the moment coefficient of skewness, which basically was given in terms of skewness is equivalent to the ratio between the third moment and this is going to be the population standard deviation to a power of 3. And if we try to compare this, basically mentioned that we can have this specific second moment as the population variancy, and therefore we're going to give this relationship from this particular case. Now, having not been given this specific concept of the quartiles or the mean, mode, and the standard deviation, we're going to use the moment coefficient of skewness in trying to evaluate our specific problem set. Now, in this case, therefore, we're going to use that specific strategy, and I'm going to give that particular formula on the board. So we're going to have this one given in terms of the moment coefficient of skewness, and this is going to be given in terms of skewness is equivalent to the third moment about the mean divided by the second moment about the mean raised to 3/2 given as such. And I mentioned that this third moment about the mean basically has a relationship with the population variance, or the population standard deviation given as such. Now, in this case, we're going to have this one substituted from the specific figures. The third moment value is equivalent to 16, and of course, this is going to be the second moment. The third moment's value is equivalent to -60, so we're going to have -60 divided by the second moment is equivalent to 16, and this is going to be raised to power 3/2 given as such. So if you try to evaluate that one, of course, from of course normal evaluations, we're going to obtain a value of -0.94, and this particular value is a value of -0.94 is going to be smaller than 0, and then therefore implying that this measure of skewness is less than 0, and we are given a condition for this particular measure of skewness, which is of course smaller than 0, being given as negatively skewed, and this is going to be determining the nature of the graph which we are going to obtain from this specific data and therefore giving us the nature of the distribution. Now, suppose we are also requested to find the concept of kurtosis. We are always also going to monitor this specific set of data for the given values of this particular moment. Now, this is going to be given in terms of the fourth moment about the mean divided by the second moment about the mean and the square of that one. So this is going to be given in terms of the fourth moment, which is 162, divided by this square of the second moment, which is the square over 16. So this is going to give us the value of 0.6, which is basically smaller than 3. So we are given various range of values which are going to be compared with the 3 for the measure of kurtosis, and this of